Okay, so this video is on imaginary numbers. You're going to use this video to help fill out your notes. Go at your own pace. Feel free to pause it and rewind it if you need to. Okay, so up until now, we know square root of 25 is 5. We could even do things that aren't perfect, like the square root of 20, because that's 4 times 5, so that would be 2 root 5. So we know how to root things that are perfect and even things that are imperfect, but we've only dealt with rooting things on a number line that are greater than 0. The reason the square root of 25 is 5 is because it is a number times itself. And the reason square root of 4 is 2, because it's a number times itself. Well, if I give you the square root of negative 36, there's no number times itself that will give you a negative 36. And that's why you can't square root a negative. But in solving problems, it really limits us with our solutions, because anytime we have a negative under the root, we say we don't get any solutions from that. And that's not true. We just don't get any real solutions from that. So we have decided to define the square root of a negative 1. And the square root of a negative 1 is I for imaginary. So we can now square root negative numbers. Like if I give you the square root of negative 25, technically what you're doing is you're thinking about it like this. So the square root of 25 would be 5, and the square root of the negative 1 would be I. So if I said the square root of negative 72, well, I could use 9 times 8, because 9 is a square, but 8 has a square in it, so I need to go bigger than 9. So I'm going to go 36 times 2. Square root of 36 is 6. Square root of the negative 1 is an I. And then the 2 is still left up under the root. So just to do one more, the square root of negative 24. So that's 4 times 6, and 6 doesn't have any squares in it, so that's as big as I can go. Square root of the 4 is a 2. Pop the I out, and the 6 stays under. Okay, so all of that is just square rooting negatives. You did all that in Math 3, so that's all review. Okay, well, you can give me answers with I's in them, but you can't give me answers that have I's with powers on them. So if you have a problem and for some reason you do I times I and you get I squared, you have to simplify that. Or you get an I cubed, you have to simplify that. Or an I to the 12th. You cannot give me I's with powers on them. Okay, so we've got this nifty little chart right here that, yeah, you need to memorize. But there's a neat little way to sort of help make it make sense. And I'm all about trying to make it make sense instead of just blindly memorizing it, because I think it sticks with you longer. Okay, so I is just I. You can give me I. There's no problem with that. Okay, so I squared. Okay, well, I want you to think about this. I squared is I times I. Okay, well, think about what I represents. I is the square root of a negative 1. So is that one. And then if you'll remember the last couple of weeks, we've talked about root of cow times root of cow is a cow. So root negative 1 times root negative 1 is negative 1. So I squared is a negative 1. Now you're going to use that one the most. So I squared is a negative 1. It's just one that's going to stick with you. You're not going to have to think through all that. I promise by the end of this video it will stick with you. I cubed is one that, I don't know, tends to not stick as easy. Now you could think of that as I times I times I, but we've already defined I squared and I. So if I take I cubed and define it as I times I squared, well, I is fine. You can give me answers with I's. And we just defined I squared as a negative 1. So I just brought the I down, and I squared became a negative 1. And then I times negative 1 is negative I. So I cubed is a negative I. And I want you to think about it like this. Well, I know I squared is going to give me the negative 1, and then I've got the I left over, so it's a negative I. Now, I to the fourth, you could go I times I times I times I. You could go I cubed times 1, or times I to the 1. I think the easiest way is I squared times I squared. I squared is a negative 1. I squared is a negative 1, and negative 1 times negative 1 is a positive 1. So I to the fourth is a positive 1. And that's another one that you're going to use so often, I promise it's going to stick. Now, why does our chart stop there? Okay, well, let's think about I to the fifth. Let's break this down to I to the fourth times I. Well, what did we just decide I to the fourth was? It's a 1. And remember, you can give me an I. And 1 times I is just I. So I to the fifth is I. Now notice, we're back to the top of our chart. Let's try I to the sixth. Well, again, I'm going to pull the I to the fourth out because it's just a 1, so that sort of clears all that out. And that would leave me with an I squared. So again, this goes to 1. I squared we decided was a negative 1. So again, now we're there. I to the seventh would be I to the fourth times I cubed. I to the fourth is a 1. I cubed is a negative I. And 1 times negative I is negative I. So we're there. So the reason we stop at I to the fourth is because the pattern starts to repeat itself. If you look at I to the eighth, that's I to the fourth times I to the fourth. Well, that's 1 times 1, which is 1. So we're there. And if I'd add to the ninth, I'd be back up here. I to the 10th, I to the 11th, I to the 12th. So again, you can give me answers with I's, but you cannot give me I's with powers. The easiest one to pull out, if you can, is I to the fourth. And then look at what you have left with. Okay, so let's practice some of these. Okay, so I cubed is a negative I. I to the sixth. Okay, again, I'm going to pull my I to the fourth out. I to the fourth goes to 1. I squared is a negative 1. And that's just from that chart. I squared, I cubed, I to the fourth. And an easy way to remember this chart is like if you need to jot it down at the top of your homework or a test or a quiz, once you write your I squared, I to the third, I to the fourth is I1, and the middle two are negative. So like pretend like you just won something. I won, and the middle two are negative. So that'll help you build your chart. I to the 27th. Okay, well again, I want to pull all the I to the fourths I can out. So let's think about this. How many I to the fourths go into 27? That would take me up to 24, right? And then I'd have 3 left over. So there's 4, 8, 12, 16, 20, 24, and then I need 3 more. Okay, now here's the question, because I don't really want to have to do this every time. What do all these turn into? They all turn into 1s. And 1 times 1 times 1 times, I don't care how many I have, but all those out of the fourths go to 1. And when I multiply them all together, it just becomes one big fat 1. So here's the deal. I don't care how many out of the fourths you have in there. What I'm interested in, because they're all going to go to 1s, what I'm interested in is how many are left over. So again, I to the fourth will take me all the way up to I to the 24th. And all those go to 1. So I have an I cubed left over, and that's a negative I. Okay, so think about I to the 40th. Okay, how many I to the fourths are in I to the 40th? Well, there are 10 of them. And again, technically, I don't care how many there are. I don't care that there are 10. They all go to 1. The question is, what's left? Nothing's left over. It goes perfectly evenly. So what's I to the 40th? 1. Because it's I to the fourth times I to the fourth 10 times. So all those go to 1. And 1 times 1, 10 times is just 1 with nothing left over. Okay, look at I to the 13th. So 4 will take me all the way up to 12. So all those go to 1. And there's 1 left over to get me to 13. And again, you can give me answers with I's. Okay, 107. I don't need my calculator. I know that 4 goes into 100. Then I know it'll go into 104. So how many are left over? 3 of them. Well, you can't give me that answer, but I know that I cubed is a negative I. Okay, now we're going to just root stuff. Now normally, if I just looked at the square root of 16, I would know that that's a 4. But it's the square root of a negative 16, so now it's a 4i. So anytime you have a negative up under the root, all you have to do is pop out an I. 8's not a perfect square, but it's 4 times 2. Square root of 4 is 2. Pop the I out. There's the 2 that's left over. 200 is 100 times 2. Square root of 100 is 10. Pop the I out. 2 left over. Okay, negative 8i, there's nothing to do with that. It's fine. It's just a negative 8i. But you can't keep me with this I squared. I squared is a negative 1, so minus 1. Okay, now here's where this is going to sound really, really picky, but you have to do it anyway. When you write your final answer, these numbers take that form. Now notice, your real part's in the front, your imaginary part's in the back. I cannot add a real number to an imaginary number. Not possible. But what I can do is put my negative 1 in the front and then minus 8i in the back. Yes, that is a step that you have to do. You don't have to like it, but you do have to do it. Okay, again, 3i. Nothing to do to that. Let's see, I squared is a negative 1, so that would make that a plus 5. And again, put the real part in the front, imaginary part in the back. You should do enough I squareds to where you know that if you have a term that has an I squared on it, all it's going to do is change the sign of the term because it's a negative 1. Okay, now this one's got issues. So let's see, I cubed is a negative I. So times 6 would be a negative 6i. I squared is a negative 1. So that would make that a plus 5. And then I'll put the real part in the front, imaginary part in the back. Make sure you get your signs right. Okay, these are complex numbers. We're going to add them. And then it looks like we're going to do some lobstering. So on number 13, the big old fat plus sign in the middle means do not lobster. It just means add your like terms. So add the real part to the real part, the imaginary part to the imaginary part. Treat the i's just like x's. So that would be plus 2i. Totally fine. It's a complex number. It's got a real part and imaginary part. Imaginary part's in the back. Remember, you can give me i's. You just can't give me i's with powers. Okay, so I'm going to bring my 3 down. I'm going to distribute that negative. And then I'm just going to drop those parentheses. And then I'm going to add my real stuff. 5 minus 5, that completely cancels, so that's gone. And then a negative 3i and a positive 1i is going to give me a negative 2i. This is a pure imaginary number because it has no real part. So it is a pure imaginary number because it only has the I part. This is called a complex number because it has both a real part and an imaginary part. Now on number 15, anytime you see a negative up under the root, you have to stop and take care of that. You can't do any operations with a negative up under the root. Now, when I pull this negative up under this root, I'm also going to go in there and pull any squares out while I'm at it. So 2 plus, that's 4 times 5. So that would be 2i root 5. This negative up under this root does not change that plus sign in any way, shape, or form. It just pops an I out. This guy has no negatives up under the root, and he has no squares up under the root. So I'm just going to take my shark and run it through. So minus 7 plus 3i root 5. Then I'm going to add my real parts. Okay, now let's look at these complex parts. You have to be very careful. These are like terms, not just because they have an I, but also because they have the same number up under the root. If they had different numbers up under the root, they would not be like terms, and I would have to write them separately. So this is going to give me 5I root 5. Okay, 16 has big issues. It has negatives up under the root, and there are all kinds of squares under here. And they're not like terms because they don't have the same number up under the root. So I'm going to pop an out. 48 is 16 times 3. Don't use 4 times 12 because 12 still has a square in it. So just remember that 48 is 16 times 3. He seems to pop up a lot. So just sort of try to commit that one to memory. So that would be 4I root 3 minus 27 is 9 times 3. So that would be 3I root 3. Then you have to decide if these are like terms, and they are because they both have an I and they both have a root 3. So that would be 1I root 3. So I'm just going to write I root 3. Okay, a lot of people miss this next one because they just multiply and they get root positive 48, and then they'll go 16 times 3 and they'll get 4 root 3. And they'll say, well, I multiplied, so the negatives went away, so I didn't have to mess with any i's. But you can't do any operations with a problem that has a negative up under the root. It's almost like it's stuck. So we have to fix that part first. So I'm going to pop an I out. Now you can pop squares out of here if you want to. That's 4 times 3. I'll show you both ways. So that would be 2I root 3. And the square root of 4 is, and I'm multiplying this by 2I, because the square root of 4 is a perfect square, and you pop the I out. And some people get here and say, well, you can't multiply these. They're not like terms. Guys, you can multiply anything you want to. They don't have to be like terms. So I'm going to do outside times outside. So that would be 4. Now watch this. I squared, because I times I is I squared. And then root 3. I don't need to square root the 4. He's not underneath the root. But I can't leave that I squared in your answer. And if you'll remember, I squared is a negative 1. So that makes it negative 4 root 3. Now look how this answer is different than that one. Okay. So you can do it that way, or if you wanted to, you could have popped the i's out and then multiplied, and then gotten the square root of 16 is the 4, the I squared is the negative, and then the 3 is left up under the root. Either way, you get the same answer. Okay, 18 is a lobster. So 10, that's going to be a 20i and a negative 12i, so positive 8i minus 24i squared. I squared is a negative 1, so that's going to make that a positive 24. So that's 34 plus 8i. If you really like number crunchy stuff, this is right up your alley because that's all this is. Lots and lots of details. So very meticulous, very detail oriented, and just super number crunchy. All right, so negative 12i plus 30i squared. Again, I squared is a negative 1. That's going to make that a negative 30. I have no like terms, but I am going to put my real part in the front and the imaginary part in the back. Okay, number 20. Now remember what I said. You cannot lobster. You can't do anything if you have negatives up under the root. So I have to clear that out first. And there are no squares in 3 and there are no squares in 6. So I can't pull any squares out. But I can't do anything until I pop the i's out. All right, now I'm going to lobster very meticulously. That's going to give me a 5. Now, normally we try to do this and this in our heads and add them together, but these are not going to be like terms because they have different numbers up under the root. So doing this is going to give me a negative 1i root 6, and that's going to give me a positive 5i root 3. Okay, then this, careful, is going to give me a negative I squared root 18. I squared is going to make that negative a positive. 18 is 9 times 2, so that makes it 3 root 2. Okay, he's real and he's real, but they're not like terms. And these are both imaginary, but they're not like terms. So I can't add them together. Okay, for 21, I'm going to write it twice. And then I'm going to lobster. No i's I need to pop out, no negatives up under the root, so I'm good. So 36, and let's see, that's going to be a negative 12i, and that's going to be a negative 12i, so that's a negative 24i. And that's going to give me a positive 4i squared. I squared is going to make that a negative 4. So now I'm 32 minus 24i. It's really easy to watch this and say, oh my gosh, this is so easy. If you just follow the rules, it's a piece of cake. But if you guys don't practice this, if you don't practice this in your homework, all these little details will sneak up on you and you'll fall apart. So really, really make sure that you do your homework. And when you check it, you're checking every single detail. Is it positive? Is it negative? Is there an I? Is there not? Make sure every little detail. Don't just say, oh, I just missed the sign. Make sure you know why you missed the sign. Okay, for 22, I'm going to write him twice, and I notice I have a negative up under the roots. I'm going to pop that I out. There are no squares in 3, so I can't do that. Okay, here we go. Positive 1. Let's see. That's going to be a negative I root 3, and that's going to be a negative I root 3. So that gives me a negative 2I root 3. Okay, now be super careful here. This is going to give me a positive I squared root 9, not root 3. When you multiply roots, you actually multiply the numbers up under the roots, whether they are the same or different. Remember over here, we did root 3 times root 6 and we got root 18. So when I do root 3 times root 3, that's root of cow times root of cow, so that's a cow. So that's a 3. So let's back up. That's going to give me plus I squared times 3. Which is the minus 3. So negative 2 minus 2I root 3. And again, I'm going to encourage you to pause and rewind and go back and think about stuff at your own pace. Okay? Here's another nifty little rule about i's. You cannot give me an answer that has i's in the denominator. So on number 23, I got no problem with the negative 20. I got no problem with the 3. But you cannot give me an I in the denominator, okay? If you'll remember, I1, and the middle 2 are negative. The 2 of these that don't have an I in them are when you're to an even power. So what I want to do is I want to multiply him by something that'll pull his I from an I to the first to an I squared. So I'm going to multiply him by I over I. The reason I'm doing this is not to put an I on the top, but it's to make it so there's an I squared in the bottom. And multiplying by I over I is the same thing as multiplying by 1, so that's what makes it legal. So on the top, I'm going to have a negative 20I, and on the bottom, I'm going to have a 3I squared. Remember, the whole reason you did this is so that you don't have i's in the denominator. Well, I squared is a negative 1. So that now makes this a negative 3. And I still have a negative 20i on the top. Now remember, we don't care about the I on top. He's fine. But I no longer have an I in the denominator, so that's awesome. I do have a negative over a negative, so I can make that a positive. Now, Please don't think, oh, I just popped the negative up to the top. That's not what we did. Okay, so go through the process. Okay, 24. First thing, I'm going to clean the bottom. So that's 64I cubed. It's a single term, so I can just cube it. I don't have to write it 3 times. I can just cube it. Okay, now he's an I cubed, so I'm going to shoot to get him to an I to the 4th. So I'm going to give him an I over I. So that's 3I over 64I to the 4th. And I to the 4th is just a 1. So that's just a plain old 64. I have a 3 on the top. The only thing I need to make sure is that I don't walk away too soon. Make sure you can't reduce it. And 3 doesn't go into 64, so you're good. Okay, number 25. Again, the top has an I in it. I don't care. The bottom has an I in it. I care about that. He's an I to the 1st, so I'm going to shoot for this guy. So I'm going to give him 1 more I. Now the top, you have to distribute this. So that's going to give me 12I minus 10I squared over 2I squared. Well, I squared is a negative 1. Okay, so that makes this a negative 2 on the bottom. This is a negative 1, so it's going to make that a positive 10. I'm going to put my real part in the front and my imaginary part in the back. And then before you walk away from this problem, number 1, don't leave negatives on the bottom. That looks weird. And number 2, everybody can cheat with a 2, so let them cheat. But I'm going to let them cheat with a negative 2 to get that negative out of the bottom. So watch. Negative 5 minus 6I. Technically it's over 1, but I'm not going to write it. Make sure you understand why they both changed to a negative. Okay, 26. Now 26 is different. So I want you to look at 23, 24, and 25. And look at how all those denominators only have 1 term on the bottom. And 26 and 27 and 28 and 29 all have 2 terms on the bottom. So they play by different rules because they're married. So we're going to multiply by what's called the conjugate. Oh, there's a J there. Yeah, conjugate. Okay, the conjugate of A plus BI is A minus BI. So think about it. When you have X plus 2 times X minus 2, what happens when you lobster? The middle 2 terms cancel. Okay, so when I do this, my I's are going to cancel. Okay, just watch what I mean. So take this guy. I have an issue with him right there because he's an I and he's in the denominator. The problem is he's married. So I'm going to multiply him, top and bottom, by his conjugate. Notice I did not change the sign of the 8. Conjugate of A plus BI is A minus BI. Don't change the A, just change the BI part. Okay, so the top is going to give me 32 plus 4I. The bottom, full out lobster, 64. Then check your outside, that's a positive 8I, and check your inside, that's a negative 8I. They're going to cancel. Guys, when you do conjugates, that will always happen. But I still have to do this. But if I'm multiplying a term that has an I to another term that has an I, I'm going to get something that has an I squared, which is going to turn into a negative 1, which makes the I go away, which is the point for us multiplying by this to get the I to the denominator. So negative I times positive I is going to be a negative I squared. Well, I squared is a negative 1, so it's going to make this 64 plus 1, and that's 65. So 32 plus 4I over 65. Now, before you walk away, you need to make sure that it can't be reduced, and this one can't. There's no number they can all cheat with. So you're done. So make sure you know the difference between this top row, 23, 24, 25, and 26 and 27, because they have a totally different approach. Okay, looking at number 27, two terms in the bottom. I'm going to multiply by its conjugate. So 4 plus 2i. Again, I don't care about the top. It can have i's all it wants to. Okay, the top is a full-out lobster. So here we go. 8, and then that's a 4i, and that's a 12i. So that's a 14i. And then that is a positive 6i squared, which is going to turn that into a negative 6 because of the I squared. The bottom, I'll clean that up in a minute. The bottom's going to be 16. And check this out. That's a positive 8i and that's a negative 8i. They're going to cancel. That's why we did this. Then this is going to give me a minus 4i squared. I squared is going to make that a plus 4. So now it's clean. On top I have an 8 and a negative 6, so that's a 2. And then plus 14i. And the bottom's going to give me a 20. Now a lot of people will walk away from this and say I'm done. But you know that you need to stop, go back and look, make sure you can't reduce anything. And I can let everybody cheat with a 2. Now for some reason when people let this 2 right here cheat with a 2, they think it cancels and it's gone. It's not. It's a 1 plus 7i over 10. You have to have that 1 there. It holds his spot. Otherwise it's like he never existed. Okay, so again, on the last 5 problems, make sure you know when you just need to multiply by an I and when you need to multiply by the conjugate. Okay. 28 and 29, it's a plus sign. Well, I can't add fractions unless I have a common denominator. So if I'm looking at these, I need a common denominator. My common denominator is going to be 3 plus I, 3 minus I. Well, the first guy has the 3 plus I, so he needs a 3 minus I, top and bottom. That's what makes it legal. The bottom of the second one has a 3 minus I, so he needs a 3 plus I. Okay, now my denominator for the whole thing is 3 plus I, 3 minus I, which, by the way, are conjugates. And when I lobster them together, my i's are going to go away. But let's deal with the top. To the top, I'm going to distribute my 5i. So 15i minus 5i squared, which is going to turn into a plus 5 because of the I squared. Then plus, watch out for sharks right there. Distribute the 7. I don't have to worry about a shark. 21 plus 7i. Okay, let's see. Put my real stuff in the front. So I have a 5 and a 21. So 26 plus 22i, which is all good and simplified. The bottom I need to lobster. That's going to be 9. Then a negative 3 and a positive 3i, they're going to cancel. And then minus I squared. I squared is a negative 1. So with that negative, it's going to make it a plus 1. So now I'm over 10. And they can all cheat with a 2. So 13 plus 11i over 5. And again, I encourage you to pause, go back, just watch it again. Sometimes writing it down and listening is too much, so just write it down the first time and then go back and just watch and listen to it the second time. Okay, on 29, my common denominator. Now, this I is single, this I is married, so please don't think that this guy just needs a 2, because if you give him a 2, that's going to make him 2i, not 2 minus I. So if he's single and he's married, my common denominator is the single I and the 2 minus I. Well, obviously the first guy has the I, so he needs the 2 minus I. He has the 2 minus I, so he just needs an I. Now you do need to watch out, there's a shark there, but this is behind the shark only going to be one term. But if there is a shark there and behind it is multi-termed, you need to run it through. Let's lobster. 18, then let's see, that's a positive 2i and that's a negative 9i, so minus 7i. And then minus I squared, which is going to be a plus 1. And then minus 5i all over I times 2 minus I. Now we got real lucky over here because when I lobstered that, my I's went away naturally. On this one, we're not quite so lucky. So let's finish cleaning the top. The top is going to be 19 minus 12I. That's going to be 2I minus I squared, which is a plus 1. So 1 plus 2I if I put the real part in the front. Okay, now you've done all this work that's in pink to combine the fractions. And so here we are with our answer. The question is your answer okay? And the answer is no, because you have an I in the denominator. No, those I's cannot cancel, that they're married. So I have to multiply by the conjugate, 1 minus 2I. So both of the top is a full out lobster. So let's see, that's 19. And let's see, that's a minus 38I. And that's a minus 12I. So that's a negative 50I. And then that's going to be a plus 24I squared, which is going to make that a minus 24 because of the I squared. Over, I'll clean that up here in a second. Now the bottom are conjugates, which makes me happy because stuff's going to cancel. So I got a 1. Outside and inside are going to cancel, so now I just have to do that part. So that's going to be a minus 4I squared, which is going to be a plus 4. So now I'm over 5. So yay, no I's in the denominator. I need to do 19 minus 24. That's going to give me a negative 5. And then minus the 50I. And then they can all cheat with a 5. So negative 1 minus 10I. Okay. So that's a lot of the nitty-gritty stuff. The last little thing we need to talk about is solving quadratics. Before, when we solved quadratics and we got to where we saw we were going to be rooting a negative, we stopped. And we said no real solutions. Well, now we're going all the way. If it's a degree 4, you're finding all 4 solutions. I don't care if they're rational, which means they're pretty, or if they're irrational, which means they're ugly, or if they're imaginary, which means they have eyes in them. So you now get to represent all your solutions no matter what. But I do want to point this one thing out. If you have solutions that are imaginary, they are not x-intercepts. There's no place on the x-axis for anything with an I in it. So if you have something that's a degree 5, and you have an x equals 0, a 3, a negative 7, and then a plus or minus 4I, the only x-intercepts are these. Now it has 5 solutions. These are all 5 solutions. But these are the only x-intercepts. This is your, when we would draw it and we'd say it wiggles somewhere off in space, that's what that causes. Okay, so let's look at number 30. The goal is to factor it because that's the easiest. 17 only has the factors of 17 and 1. And neither one of those are going to work. So this guy does not factor, but always try that first. We also talked about completing the square, and I want you to be super comfortable with that, and we are going to do that on one of these. But this one is not a nice complete the square. This number is nicely halfable, but if you'll remember, you cannot complete the square when it has a leading coefficient. So I'm not going to complete the square. I'm going to go straight quadratic formula. So here we go. Opposite of b, square root b squared minus 4ac all over 2 times a. Now when you do this, grab your calculator, but don't start with the 6. I don't want decimals. I want to know what this number is. So you can do 36 minus 4 times 3 times 17. So go ahead, grab your calculators and do 36 minus 4 times 3 times 17. Practice typing this in. So pause it, get your calculator, and type that in. So it's 6 plus or minus the square root of a negative 168 over 6. Okay, so you see the negative up under there, so you know it's going to be an imaginary. But you have to dive into 168 and you have to go square hunting. Start with 4. See if 4 goes. So do 168 divided by 4. I got 4 times 42. Now I need to make sure there are no squares in 42. So I need to make sure 4 was the biggest one. Well, 42 is 6 times 7 and 6 is 2 times 3. I have no pairs here to make a square. 4, 9, 16, 25, 36. None of those numbers go into 42. So this is my biggest square. Now watch how this works. This 6 stays put, plus or minus. Then when you square root this 4, the 2 comes out after the plus or minus. It sits right here. And I have to pop the I out because of the negative. And then I have my root 42. Do not square root this 4 and bring it all the way out here and multiply it by this 6. That's a completely different term. And this is still all over 6. And a lot of people will walk away right here. But the top is married. It's a 6 and then a 2i root 42. Those are your two terms on the top. So they're married. But they can all cheat with a 2. Now when you cheat, you do not touch underneath the root. An outside number, a number that's not under the root, cannot reduce with a number that's in the root. But this is one big happy term. So we're reducing this 6 with a 2. So I'm going to take a 2 from everybody. So 3 plus or minus, you can put a 1 there if you want to, I root 42 all over 3. Can you cancel the 3's? No, because the 3 on top is married. So that's it. There's your answer. Okay, 31. I know some of you are a little grumpy on completing the square, but you need to suck it up and you need to make sure you know how to do it. This is a beautiful complete the square. It does not factor. There are no factors of 17 that are going to give me a 6. There's no coefficient, and that number is very nicely halfable. Now make sure that you know the difference. Okay, so make sure you know the difference between this and getting it into parabola form. This was Grandpa. We would just slide him over, and then what you did here, you did the opposite here because you were on the same side of the equals. This is different. You're solving it. So what I'm going to do is I'm going to take Grandpa, and I'm going to subtract him over to the other side, like taking him over to the neighbor's house. I'm going to take my 6, I'm going to half it and square it, so I'm going to get a 9, and I'm going to add 9. Always add because you're always squaring. Remember, that's on the left-hand side of the equals. So when you come over here to Grandpa, you're on the right-hand side of the equals, so what you do to one side, you do the exact same to the other. When you're getting into parabola form, what you do here, you do the opposite here because you're on the same side of the equals. Make sure you understand that and not just try to memorize it. This is my perfect square, so that's going to be x. The minus comes from right there. You root that guy, gives you your 3. That's same old, same old. A negative 17 and a 9 is a negative 8. And then I have this square, so to get rid of it, I'm going to root both sides. So the x minus 3 falls out. Now when you root both sides, you have to remember to put that plus or minus. So plus or minus, 8 is 4 times 2, and it has an I. So 2i root 2. And then you add the 3 over, and if you'll remember, I said put the pretty in the front, plus or minus ugly in the back. Now, some of you are still probably really grumpy about completing the square. Again, you have to learn how to do this. If you get in a jam, yes, you can do the quadratic formula with him, but watch. You'll get the same answer. Opposite of b, b squared is 36, minus 4ac all over 2a. 36, let's see. 36 minus 4 times 17 is a negative 32. 32 is 16 times 2, so that's a 4 and an I. And then let them cheat with a 2. Same thing. But don't you dare shy away from completing the square. I cannot stress that enough. You have to know how to complete the square. And you can just say, well, she said I can get the same answer with the quadratic formula. Guys, I know what's coming, and you need the practice with the complete the square. There are things that are coming where you have to know this process, okay? But if you're super paranoid about it and you want to check it this way, that's totally fine. Okay, then we get to this last one, or the last two. Let's see. It looks like a cute little trinomial. Like, let's try to go 2 and 2, or 4 and 1, or 1 and 4. Trying to get a 2. 10 and 2, 5 and 4, 20 and 1. Nope, no way I'm going to get a 2 out of this. So it does not factor. It is not a nice complete the square because of the 5. So I'm going to go quadratic formula. So the opposite of b squared minus 4ac. I can already tell it's going to be negative up under the root because this is bigger than this. Over 2a. Let's see, 4 times 5 is 20. 20 times 4 is 80. 4 minus 80 is a negative 76. I know I can pop an I out, but I got to go hunting for squares in a 76. Always start with 4. And this one happens to be 4 times 19. So 2 plus or minus 2i root 19 over 10. And everybody can cheat with a 2. So 1 plus or minus, please don't forget that 1. I don't have to have the 1 here because I still have the I in the root 19 over 5. Okay, now 33 is a really good problem. Okay, I'm going to erase this so I have room. 33 has large numbers, and there is no GCF. 24 and 26, the only numbers that will go into those are 2, and 2 doesn't go into 63. 4 doesn't go, 9, I mean, there's nothing. 7, there's no GCF. This would be a hideous complete the square, so I'm going to go quadratic formula, but it's going to be ugly. So here I go. 26 plus or minus the square root of. Now, technically your b is a negative 26, but I know when I squared it's going to be a positive. I don't know what 26 squared is, so I'm just going to write 26 squared. Now, technically it's a negative 26 squared, but I know that when I square it's going to be a positive, so I'm just going to drop the negative. So 26 squared minus b squared minus 4ac all over 2a. So 26 plus or minus. All right, then you grab your calculator and you do 26 squared minus 4 times 24 times negative 63. And you get 6,724 over 48. Now you have the daunting task of diving into 6,724 and finding a square. Okay, now this sounds sad, but I'm going to take 6,724 and I'm going to divide it by 4. I'm just going to start hacking at it. So I got 4 times 1681. I'm going to divide that by 4 again. All right, it doesn't go. But 1681 ends in an 81, so I'm going to try 9. Nope, 9 doesn't go. 1681, let's see, 4, 9. 16's not going to go if 4 doesn't go. 25 doesn't go. 36. Let's try 49. Nope. 64 is not going to go. 64. 81 won't go since 9 didn't go. Let's try 121. Nope. 169. Nope. 6724. All right, I'm going to pause this while I find it. Okay, so it turns out that 1681 itself is a perfect square, and it's 41. So this is 41 times 41. So if this is a square, which is 2 times 2, and this is a square, which is 41 times 41, if everything inside this number is a square, then guess what that means about that number? It means that that number is a perfect square. So I'm going to square root 6,724, and I get 82. Now here's how I knew I should have gotten 82. Well, the square root of 4 is 2, and the square root of 681 is 41, and 2 times 41 is 82. So here's what I have. I have 26 plus or minus 82 over 48. Notice there are no i's. There are no numbers left up under the root because it was a perfect square. And here's what some of you are going to do on the test. You're going to stop here and you're going to walk away. But guys, can't we add 26 plus 82 and get a number, and then do 26 minus 82 and get a number? So 26 plus 82 is 108. So I have 108 over 48, which is going to reduce here in just a minute. And then 26 minus 82 is a negative 56 over 48. Now I'm going to reduce. I'm just going to type it in my calculator. 108 divided by 48, get a decimal, and then go math fraction. I got 9/4. And then negative 56 divided by 48, and I got a decimal. And then I'm going math fraction, and I got a negative 7/6. So these two guys are my answers. Okay, now hold on a second. There are no i's. There are no roots. They're just cute little fractions. So let me show you what this means. What this means is the original problem would have factored. If these are your solutions, what factors would they have come from? 4x minus 9 and 6x plus 7. And 24 is 4 times 6. And 63 is 9 times 7. And that gives me a negative 54. And that gives me a positive 28. And that gives me my negative 26. So, but there was no way I was going to go factor that. So, be prepared for this number under here to be a perfect square, to end up here, but to not stop there. I get lots of, there's one on the test where some people don't like to factor it, so they'll go 2 plus or minus 5 over 3. And I count that wrong, because 2 plus 5 is 7 over 3. There's one of your answers. And 2 minus 5 is negative 3 over 3, which is a negative 1. There's your other answer. So if this happens where you have no root back there, then you have to keep going. Or you need to recognize that it factors from the get-go. But I would not have done that on 33. Okay, then you've got these cutie little last problems, number 34 and 35. And we've kind of dealt with this before. Notice that these are quadratic, but they're missing the middle term. And when that happens, just solve for x. Subtract your 49 over, so he'd be negative, and then root both sides. Now again, when you root both sides, you have to put that plus or minus, and that would be 7i. Now 35 is the exact same thing. It's missing that middle term, so I'm going to subtract the 24 over, and then I'm going to root both sides. So I get my plus or minus because I rooted both sides. 24 is 4 times 6. So 2i, because there's a negative up under the root 6. This answer is imaginary. This answer is imaginary and irrational. Technically, this one's irrational too because I equals the square root of a negative 1. These answers are rational because there's no root. Okay, so I can't stress it again, and I see it every year on the test. When you do this homework, guys, do it like with crazy, crazy precision for negatives and roots and i's and powers and pluses and minuses. This is not difficult, and you'll get the hang of it, and it'll go like really, really fast. But be careful that your brain doesn't go faster than your pencil and you make careless mistakes, because that's not what you want to do. So take your time, really, really check your answers on these, every little detail. If you missed an I, make sure you know why. If you missed a negative, make sure you know why. Just check every little detail.